Last time we had this integration by parts problem. That we had to solve by back solving, which means we did integration by parts a couple of times. We ended up with the same integral we started with, modulo a different constant. We pulled it over the other side and we solved for it. Now I'm going to show you how you can do the same problem using the short method and look at the difference in work. There's what we did last time. Here's the short method. All right, if you recall the short method, what do? You start with the problem and you decide what u is going to be. Now, last time I said it didn't matter if u is the trig function or u is the exponential, and that's true. It's going to work out regardless, okay? But so let's let u be sine x like we did above. Then dv has to be everything else, so that's e to the 2x dx. Remember, in the short method, we don't write dx, we just write e to the 2x. Now, what do we do in the u column? The answer is take a derivative. What do we do in the dv column? The answer is integrate. All right, so we start with u being sine x, then its derivative is cosine x. The derivative of that is minus sine x, and that's where we stop in the back solve. Where do we stop? When we're close to where we started. All right, sine x here, sine x there. That's the hint to stop. All right, now what do we do with e to the 2x? That's dv. We integrate it. E to the 2x, the first integral is 1/2 e to the 2x. The next one is 1/4 e to the 2x. And now, how do we write down our answer? Well, it's going to be u v. Remember, this is dv, so our first v is right here. So it's uv. Oh, by the way, don't forget to alternate the sign. So I put plus here, minus here, plus here, and we're going to take that into account. So it's uv sine x e to the 2x divided by 2. There's the first term. The next term is this times that with this minus sign. So it's minus 1/4 cosine x e to the 2x. And then finally, when we're back where we started, remember going straight across corresponds to the last integral in integration by parts. And it's going to be a minus times a plus is a minus. So you get minus 1/4 e to the 2x sine x dx, and I can take the quarter out. And now what's the point? The point is that this integral is exactly that. That's what we saw last time. So I could take that over to the other side. So I take a minus 1/4 of that integral over the other side. Just like last time, that gives me 5/4 of that integral is equal to this thing, which I've written there, plus, remember, an arbitrary constant because no more indefinite integral on this side. But it's not going to be the same arbitrary constant I end up with, so I don't call it c. I call it c hat. By the way, some of this stuff you might be able to do in your head. So I get 5/4 of the integral I want to know equals this. Just like I did above, I divide everything by 5/4, which is the same as multiplying by 4/5. And 4/5 times 1/2 is 2/5. And 4/5 times minus 1/4 is minus 1/5. And then I'm going to have 4/5 of c hat. But 4/5 times an arbitrary constant is just an arbitrary constant. And you see in 3 steps of the short method, I have my answer. And if you're a little bit skeptical, last time we did all this, ended up with that answer. Using the short method, I get the same thing. And that's all I have to say about integration by parts.